been really designing reinforced concrete beams and columns, but now I want us to shift to steel. Okay, because remember, beams, we can either make them out of reinforced concrete, but also you can use steel as an option. Okay, so most high-rise buildings actually are made of steel. So, if this is what you're interested in, let's get into it. All right. Okay, so there's different types of steel. There's what we call mild steel, high carbon steel, cast steel. All of these are just different, and the difference between them is the amount of carbon in them, because carbon is the main ingredient of steel. All right. Okay, let's go on. Now, there are some advantages and disadvantages of steel, such as, well, an advantage, high strength per unit weight. Steel is really strong. High elasticity, meaning it can, bend if you want it to bend. It's elastic. The performance, it performs real good, especially when well maintained. Yeah, when we're speaking of performance, we're also talking about its strength, that it performs very well. Ductility, toughness, disadvantages of steel, it corrodes, so it needs to be protected from corrosion. There are different ways to protect it, such as painting it, spray painting it, coating it, whatever. You need to fireproof it as well, because it behaves very badly when it comes to fire. Steel melts under fire. So when it burns, unlike wood, remember wood, when it burns, it can warn you in that it burns and then it cracks little by little until the whole thing falls. But with steel, it's not so simple. With steel, it burns, and once it reaches a certain point, it just fails. So it's mostly dangerous when it comes to fire. So it needs to be fireproofed. Okay, susceptible to buckling. Buckling is just bending. It can break easily. It can bend easily. If you go over the limit, it can carry fatigue. Fatigue, yeah, it's talking of it being tired. So over a long time, still gets tired, it loses strength. So that's what we're talking about when we're talking about fatigue. Fire safety. So one of the measures you can, fireproof steel is by putting concrete around it, because concrete is very good when it comes to fire resistance. It can resist fire, concrete. Recyclable steel is recyclable, as you know. Here in South Africa, as you know, whenever, especially in the cities, whenever you see people, on the streets pushing carts with steel in them, it's because steel is very, recyclable. So they take that to the recycle centers so that it becomes recycled. Now, these are just some different structural steel sections that are used in industry. Okay, so we have what's called I sections. Okay, H sections, as you can see, the I section is shaped like an I, that's why it's called an I section, with a long web. And then the H section is called an H section because the shape as well, it's shaped like an H with long phalanges. Okay, this is still I section with tempered phalanges, which means tempered. Tempered means that, it's sort of curvy, and it's been made with curves, as you can see there. And then you've got this one, which we call a channel, because as you can see, the C, it starts with the C as well. So instead of calling it a C section, they call it a channel, but it's shaped like a C, as you can see from the pictures. And then you got this one, equal angle. It should have been called an L section because it's shaped like an L, but instead it's called an angle. Okay, so you can see it's shaped like an L. Also this one, unequal angle, shaped like an L. And then we got this T section here. Well, you know why it's called a T section, because it's shaped like a T. Okay, and then it's a flat, a square, and a round. Okay, so they got different uses. Okay, so when it comes to beams, really, when it comes to beams, mostly you use I sections to make a beam. So we use an I section together with joists. You will know just now as we continue what a joist is. You will see. And then when it comes to columns, normally for columns we use H sections, but also you can use I sections as well. It's just the common one is the H section for a column. Remember, a column stands up straight and a beam is kind of horizontal. Okay, and then channels and angles. Let me just put the video up there. For channels and angles, we normally use them, and T-bars as well. We normally use them on the roof truss. Normally, we use channels for roof truss to, kind of put the roof on the top, the roof sheeting on top of the C, and at the bottom of the C, that's where we join it to the beam or whatever. So they all have different uses when designing. Okay, all right. So here we go. General, just the shapes again. That's an H channel. It looks like that when it's standing upright. H section rather. This is a channel shaped like a C, a square. As you can see, it's a hollow square. An angle, it's not called an L, but it's called an angle. And then a T. All right. Okay, so different shapes. This is just saying that there are different shapes in steel. It's T section, I section, channel H, we've spoken about this and you've seen them. And then we have bars. Okay, so now these are bars. Okay, as you can see, we got square ones and round ones. And how many sides are this? 1, 2, 3, 4, 5, 6. Hexagonal, and then all of these. So they are used as ties and lateral bindings. Okay, ties, as you can imagine, is to join things, like to ties. Comes from the same word as tie. Okay, so it's kind of the same principles that it joins, but you will see demonstration as we go on. Types according to manufacturers, well, there's different kind of bars as well. Cold rolled steel bar, hot rolled steel bar, galvanized steel bars. All of these are different types of bars. Okay, so we got round bars, square bars, hexagonal bars, and flat bars. Those are just the type bars. This is just some information on round bars. Not really important. Equal angle section available in section. These are just information on equal angles. There is the picture of equal angles. Once again, these are just demonstration of them. More information on equal and unequal angles. As you can see in this picture there, angles. And then channels, there are channels shaped like a C. The reason we're repeating this is so that we can kind of cement it in your head, so that when the exam or test has a question and it asks you to draw a channel, you will know exactly what to draw. It's shaped like a C. Okay, T sections, that's a real practical example of T sections. There we go. I sections, practice. Now, the connection of steel, right? So when you are connecting steel, there are basically three ways you can connect steel. Like when you're, let's say you're doing a beam and a beam and you want to connect those two sections, you either connect them with bolts, rivets, or welding. Okay, let's go through each one of them. Okay, so joining members, there's a rivet. As you can see, this is a picture of a rivet here. What is a rivet? We'll get to it, but here it is. As you can see, it sort of looks like a nail. You just nail it in. And then bolts, bolts and nuts. So bolts you tie on both sides of the steel. And then we got welding. Okay, so welding, you know, is another way you can join the steel. Okay, let's start about bolting. Let's talk about bolting. The reason we're starting with it is because it's the most common method in joining structural steel. You will see that everywhere you go and you look up at steel, how it was joined, you most likely see bolting because it's very common. So as you can see, these are hashed out, are the two steel members that are being joined, and you use bolts. As you can see on one side and nut on the other side, just to join them. Okay, so you're joining two here, two there, you're joining three here, three steel members, four over here. So, bolting is very popular. Okay, so it's used when desired to have temporal connections. Well, temporal in a sense that you might want to remove them later. Okay, so if you want to make a temporal structure, such as let's say you're using your steel to make um, what's that thing? That's scaffolding. Okay, so you probably use bolting over there. You're not gonna weld scaffolding because welding is more permanent. Okay, so if you have a temporal structure, you're most likely gonna use bolts. It may also be adopted when difficult to use rivets is connecting members. Bolts are better suited for tension applications. So they're very strong in tension because, as you can see them, they are very thick and long. So they are very good with tension. So it makes them strong. Okay, so four types of bolts. You got black bolts, tension bolts, torsion bolts, load indicating bolts. Now there's really different types of bolts. Let's just look at black bolts. These are the common ones. I'm sure you've seen it everywhere you go, every house, every object that's made of steel probably has this bolt, because it's the most common. Okay, there we go. Here's a practical example where you can see it in in um, in construction. This is a beam and it's got a series of bolts connecting it. Okay, so torsion bolts, as you can see, normal bolt, and then it has a nut and a washer. Okay, so it has an addition of a washer. This is a washer. So nuts are the connecting member, the screwing member of the bolt. Okay, so different types of nuts as well. As you can see there, these are some nuts with some washers, bolt and nuts. Okay, they always go together. Now let's talk about rivets. A rivet is a permanent mechanical fastener. It's more permanent. Like I said, imagine a nail. That's a rivet, a nail. It's a form of a nail, but the nail for particularly steel, we call it a rivet. Okay, so before being installed, the rivet consists of smooth cylindrical shaft with a head on one edge, just like a nail. Okay, the end opposite the head is called the tail. All right, because there is effectively a head and each of the end is installed rivet, it can support tension loads. So it's also good in tension, just like bolts. Okay. So here we go. Here's some rivets here. As you can see, they are like nails. Okay, there we go. As you can see, a rivet there, rivet, rivet, rivet. It's more or less shaped like a nail. You don't screw it in, you just push it in. Okay, so, and then let's talk about welding. As you can see, here's an example of welding there. It's permanent. A welding joint is a point or edge where two or more pieces of metal or plastic are joined together. So you join them together. 5 types of joints. It's important. There's a butt joint, corner, edge, lap, and T. Let's look at each one of them. We will take a look. The basic method of welding are acetylene and electric arc. This is a tough word. Classified as fillet or butt weld. So let's just stick there. This is the important part, that it's either a fillet or a butt welding. Okay, so a fillet is used to the edges and end of members, but butts used on chamfered end to end connections. Well, let's take a look at what these things actually mean. Okay, so here we go. Taper joint. As you can see, a T-butt joint. This is a fillet welding. It's done like that, joining like that. So you see, this is a fillet. Wait a minute. Butt, lap joint. Okay, a fillet butt. How am I reading this? Wow. Okay, I see. Well, this is not very clear. So let's look at a different example. Square bolt weld. So this is the welding over here, the black one. V-shaped welding over there. J-shaped over there, and then a surface welding. Okay, so if we look at this example here, you can see that there are different members here, and all of them are welded, but it's not very clear what's going on. Okay, so these are the types of joints that are done in steel. Either you do column based, or which means it's joining a column to a column, or a beam to a column. So a beam is like horizontal, column is vertical, or you do a beam to beam joining. These are the types of joinings that you can do. Now, in doing those types of joinings, it's either you can use bolts, rivets, or welding, depending on which one, or a combination, depending on your design. Okay, so here is a column-based design. This is what you will be drawing in the tests or exams. This might be a question that they want you to draw. But let's take a look at the practical side on this picture on the right. As you can see from this picture that you have a column really, and it's being joined to a base of a foundational base. Okay, so as you can see, there's a bolt over there, but here's the drawing over here to see what's going on under, this bolt. So you've got your column and your bolt and your washer, and then you've got your steel plate over there. And then, as you can see, the bolt goes all the way until the end there, where it's fastened with a nut. Okay, and then grouting all around, just to make sure the foundation is stable. Okay, so this is column based, so it's just a column at the bottom of the column. All right, this is another example of a column base. You can see this is, what do you call this? Remember what an L-shaped section is called? It's an angle. Okay, so as you can see, the one part of the angle is anchored to the foundation, and then the other one is anchored to the column itself. Okay, these are some more base connection. As you can see, it's a combination of welding. I'm looking at this picture on the right with some nuts as well, bolts and nuts. Okay, and then this is just another representation of the connections that are made. It's either you do column to column or beam to column. So here is an example. This one looks a little bit weird, but let's take it little by little. Now you've got this column, this H section of a column, and then the beams are the I sections. Remember, I told you that for beams, we normally use I sections, and columns, we normally use H sections. So this is a connection between a beam and, well, 3 beams. 1, 2, 3. I don't know if there's a 4th one on the other side that we can't see, but the important part is that we're joining beams to a column. That's how it looks like. Okay, so direct connection, this one was welded. Is a column and beam, column and beam. Here's a practical example of a beam to column. Now this one has 4 beams on the sides of the column, and all of them are I section, the beams, but the column is the H section. Here we go, beam to beam. Now this is a beam to beam connection. We're just looking at the top of a column where you're joining a beam to another beam. Let's look at it as well. A more practical example, beam to beam, beam to beam. Beam to beam, even though there's a column, but really what we're focusing on is the beam. As you can see, the beam, once again, I section. Okay, so here's a beam to beam connection. As you can see, you also use an angle there to join a beam to another beam with bolts. Okay, it's another example, beam to beam with bolts. Well, this is just a picture. Now this one is a column to column. As you can see, you've got a column on top and at the bottom with bolting and a plate, and then you bolt them together. There we go again, column and beam connection. Now in the exam, they can ask you to draw any of these. Okay, and I think my idea was just to demonstrate it to you how it actually looks in many of those examples over there. So